Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is the second video regarding how to use the binary logistic regression to come up with a model, then calculate a probability and use any of the AI available, maybe to come up with a simple calculator in order to maybe calculate the probability without undergoing all this process. So in today's example, we're going to see how we can develop a kind of model that can predict whether it will rain today or not. Mostly in all our mobile apps, so you normally see all these weather applications that can predict and tell you the chance of raining today. So actually, it's not something difficult. So with the binary logistic regression and all this AI available, you can come up with your own simple maybe calculator or mobile app that can predict this. But the only problem that is hindering us from uh, doing all these things is a lack of data. We don't have record actually. Like for instance, maybe if you want to predict the chance of raining, you will need the maybe the humidity, the cloud cover, the barometric pressure. Maybe you need these variables. So actually, where to get this variable is where the problem is. But maybe once you have these variables, so you can be able to come up with the binary logistic model, and from there you can be able to predict whether it will rain or not based on the previous data. So let us delve into the problem and try to see how we can go about it. So normally, when the air is humid, that means there is a lot of moisture in that particular air, and the tendency of cloud to form becomes high. And this is like a basic knowledge from our geography and those that do civil engineering or the geologists from our course of from course hydrology, one can be able to get this basic concept. So, and this is the barometric pressure, and the higher the barometric pressure, the lower chance of raining, and the lower the barometric pressure, the higher chance of what? Rain. When it is high, the chance of rain is very low, and when it is low, the chance of rain is very high. So maybe these are previous data are obtained in the first day when the humidity is 85, the cloud cover was 90, and the barometric pressure is 1008, and it rains. So since it rains, we now code it as 1. In the second day is 60, then the cloud cover is 40, and the barometric pressure is 1, and it rains. So we code it as what? As 1. So that is how uh, to go about the data. Like I explained in the first video, how to calculate the probability. I said it's just 1 all over, then 1 plus the exponential minus uh, the sum of the what of the model you developed. So you see the first one, the beta naught is the constant, then the beta one is your what? Is your tangent or the coefficient of the first variable, which is the humidity. Then the beta 2 is the constant or the what? Sorry, is the coefficient of the second variable, which is the cloud cover. Then the B3 is the this thing is the tangent or the coefficient of the other variable, which is the pressure. So let me just quickly go to the SPSS and try to run this so that we can be able to get the model. So I will just copy the data. So in the first video, I have shown how the variable are done. So we'll just go to the data view. So I will just paste this copied data. Okay, now I'll go to the analyze, then try to locate where the regression is. Then from here I will just move down to the binary logistic regression. So the dichotomous data, which is the chance of raining, it has two outcomes, whether it will rain or not. So it will go to the dependent variable. Then these three other predictors, they will now go to the what? They will now go to the independent variable. So I'll come to the option. Then I will now choose the 95% chance of sorry, confidence interval. So I will now click on continue and I will now click on OK. So let's go to the model. So this is the model, and this is the coefficient of the humidity. This is the coefficient of the cloud, and this is the coefficient of the pressure, and this is the constant of the equation. And this is the what? This is the odds ratio. So what this means is that for every unit, the humidity uh, increases increases the chance of the rain happening by 1.113. So it goes like that. So in the first video, I explained what the table is all about. So now we just copy this the constants. Sorry, I will copy the constant together with the coefficients so that we can calculate the probability. So for the humidity, I have 1.113. So maybe I will come back here, come back here. It is all this way. So I'll come back here. Under the humidity, I have 1.113. Then, sorry, I should be this 1.113. Then for the cloud is 0.867. So the cloud cover is 0.867. Then for the pressure is what? Minus 0.798, minus 0.798, minus 0.798. Then my constant is what? The constant is 673.57. That is 673.57. 673.57. So now I have the coefficients and the constants. So all what I just need to do is to calculate the probability. So this is the formula we use. So we will now say equals to, then we can now say 1 divide by, then we can open a bracket and say 1 plus what? 1 plus, then we will now write the exponential. So when it appears, then we will now what? Double click on it. So you see there is a negative sign, like I explained here, is that when you now get the output of this model, then if you introduce the negative sign, it shows that utility, because what you are calculating is utility as this thing. So the higher the utility, then the lower the probability when the negative sign is introduced. So we will now introduce the negative sign, then we'll open the bracket. So you see the first one is the constant. So I will now select the constant, then I can now say plus. Then the second variable is the coefficient of the humidity times what? Times the humidity. So I can now say this, then to be multiplied by what? So let me just use this column where I can impute the value of the humidity. Then plus what? Plus the next one, which is the coefficient of the cloud cover multiplied by the cloud cover. So I can now say this, then multiplied by what? By any column or any cell that I want to inside the cloud cover value in. So you can now say plus. Here you can use the plus because this is a negative, so it will still make it a kind of a negative. So I can say this multiplied by my word this. So remember to close all the brackets. So the first one and the second bracket, how many brackets? I think it's okay. So now with this, you can be able to calculate the probability. Like for instance, let us just use a kind of a hypothetical data. Like for instance, let me just say the humidity is 70, and let me say maybe cloud cover, let's say is 40, and let's say the pressure, let me say is 1000. So you see, the probability is very minimal, 0.00 something. So as you are changing the variable, the possibility of the rain happenings will also be, you see, when the humidity is 90, the cloud cover is 40, and this, so the chance of raining is 0.99. So now let us go to the Qwen, and then try to come up with a simple calculator that can predict the chance of raining, maybe. And maybe you can even give it a command to say that maybe if the probability is greater than 0.5, it should write a kind of a caution word, like make sure to bring your umbrella with you or something like that. So let us go to the IQ. So now, okay, this is the one we did yesterday. So I will just go to a new chart. So I will just write a command. Let me just say this is a like a binary logistic uh, model. So you can now write the model. So let me just see, it's 673.53. Okay, 673.53, then plus what? Let me check it again. So 1.113, 1.113 multiplied by what? By humidity, then plus what is the coefficient of the cloud cover? The coefficient of the cloud cover is 0.867. So I can now say 0.867 multiplied by the cloud cover. Then you remember the coefficient of the pressure is what? Is negative. So here I will write negative because it's minus 0.798. So minus 0.798, then to be multiplied by what? By the barometric pressure. So let me just write the pressure. So I can now give the command of what I want the Qwen to disable. Remember to click on this artifact. So I can now say, okay, create a calculator that can predict the chance of rain or the probability of raining from this model, from this watch model. So now you can even give it a kind of a command to let's say maybe let's say uh, if the probability is maybe let's say greater than what? 0.5. So let me say ensure to write when in the output, let's say output to bring, let's say, your what umbrella. Then the correct spelling. Let me say otherwise dot. So let's just leave it like this. So all this one is just simple grammatical error. So let me just run this. So you can, you see all these the Python code that is being generated. So you can you can copy it to the Python compilers. If you don't want, it will also give you the compiler beside the script written. Then you can deploy that particular script and share the link to others so that they can access your work and maybe try to. So you see it has already done that. So now we just have need to impute this. So let's say this is 70. Let's say this is 70. Let's say the cloud cover is 20. Let's say the cloud cover is 40. And let's say this is 1000. So you can say predict rain. So you see it says probability of rain is 0, 0. So no need for an umbrella. So let's just make this 80 and see 80. Then let's say predict. So you see probability of this is 32 point this. So no need for an umbrella. So let's just try and check whether this one is in conformity with what we obtained manually. So when we have 80, when we have here 80, then what is the cloud cover? The cloud cover is 40. So let's just say enter. So you see it has given us a probability of 0.32, which is the same thing with this, which is 32.08. So if you want, you can deploy this. So once you click on this deploy, so you can just deploy it. So after deployment, it will give you a link. So you can copy this link and you can share this link with whoever that you wish to share the link with. So let's, for instance, let me just let me just show you how the link works. So let's say I decide to paste the link. So this is the link. So once you click on the link, so it will automatically takes you to the Qwen calculator generator. So it will just give you the output of what you have just listed. So is it? Qwen. Or you can just copy the link to any browser, it will still work. So let me just copy it. Let me say new. Seems like I have problem with my connectivity. So you can just paste the link. So, just search it. So it will automatically take you to the build calculator so that you can just impute your variables and predict whether it will rain today or not. But the only challenge we are having in this part of the country is we don't actually have this data, and the government is not trying to make it possible. So, like for instance, now for you to get all this the humidity data and maybe the cloud cover, barometric this thing. So maybe you need to go to this institution. So you can see if you just click on the link, so it will take you to the calculator you have built. So from here you can be able to try to predict whether it will rain today or not from the watch, from the real life data. So you just collect the pressure, the humidity, the cloud cover, then you can say predict. Will tell you that this is the probability and no need for an umbrella today. So something like that. So assalamu alaikum. In the next video, we're going to see how we can use this maybe to help with those maybe patients suffering from kidney diseases and the rest. So actually, we can do a lot, just that maybe we are not willing to. So assalamu alaikum warahmatullahi.